What's up, my pre-calc people? In this video, we're going to talk about topic 3.6 out of AP Precalculus over transformations of our sine and cosine functions. Now, we should know the basics of sine and cosine from our previous video, but now what we want to talk about is all the different transformations that can take place to them. Now, what we see here are our basic sine and cosine functions with many transformations done to them. We have an a, b, c, and a d value, and all four of those values apply a very specific type of transformation to our sine or cosine graph. So let's start talking about them each right now. In these functions, there is a vertical dilation by a factor of a. This vertical dilation is going to affect the amplitude. So basically, the amplitude becomes the absolute value of a. So if there's an a value of 5, our amplitude is going to shoot up to 5, and of course down to negative 5, because remember the amplitude is half of the total distance between your min and your max. So if we go from negative 5 to positive 5, that's going to be a distance of 10, cut that in half, and we get an amplitude of 5. So again, that a value out in front is going to be a vertical dilation by a factor of a, impacting the amplitude. Now the d value in the back is going to create a vertical translation, moving the function d units. So it's a plus d, the entire graph's going to go up. If it's a minus d, the entire graph's going to go down. So if we see a d value of, say, 7, the entire graph is going to move up 7, or if we see a d value of negative 9, the entire graph's going to go down 9. Now this is going to impact the midline. So basically, remember, the midline of a sine or cosine function is 0. But if we add 5, the entire graph's going to go up 5, and now our midline is y equals 5. If we subtract 9, the entire function is going to move down 9, and now our midline is y equals 9. So whatever that d value is going to be your new midline. Next up, we have a horizontal dilation by a factor of 1 over b. Now you got to remember back to our basic transformations, when we multiply inside of our function, that's going to be a horizontal dilation, but it's not a horizontal dilation by a factor of b, it's by a factor of 1 over b. This is going to affect our period. Remember, our period of our function, sine and cosine, is 2 pi. But if we stretch that or shrink that, we could affect that period length. And that is going to be done by b. So the new period of a function, sine or cosine, with the transformation is going to be 2 pi divided by b. Because remember, you're multiplying it by 1 over b. That's why it's 2 pi, the original period of sine or cosine, and then multiplied by 1 over b, which is going to create 2 pi over b. So anytime you have a b value there, you're just going to take 2 pi divided by that b value to get the new period of your function. If your b value is 5, that's going to cut your period smaller. So now your period is 2 pi divided by 5. If your b value is 1/5, then you're actually going to multiply by 5. That's going to make your period bigger. And lastly, the c value is going to be a horizontal translation by negative c units. So remember, if there's a plus c, you're actually going to go left c units. If there's a minus c, you're going to go right c units. Again, that stems back from what we learned about transformations way back in Unit 1. Now, we got to be a little bit careful about horizontal translations, because remember, sine and cosine graphs go forever and ever and ever in both directions. So if you take a graph that goes forever and ever in both directions and you slide it left and right, sometimes you don't actually notice that translation because it was just moving to where the graph already was. So I like to keep in mind this. Remember, sine always starts at 0, 0. It goes up to its max, down to its min, back to the midline. So if we see that that 0, 0 point got moved left or right, there's a horizontal translation. Cosine always starts up at its max and then goes down to -1, back up to +1, where it ends at 2 pi. So if we see that that max is starting left or right, then we might have a horizontal translation left or right. Honestly, for these sinusoidal functions, horizontal translations tend to be the trickiest just because it's hard to recognize them when your graph already exists forever and ever left and right. So here's a summary of all those different transformations we just talked about. We have a vertical dilation by a factor of a, affecting the amplitude, a vertical translation by d units, affecting the midline, a horizontal dilation by a factor of 1 over b, which is going to change the period to 2 pi over b, and a horizontal translation by negative c units, which is going to move the graph left or right. But we could also have reflections. If there's a negative out in front of that a value, that's going to be a reflection across the x-axis. If there's a negative inside the function on our b value, that's going to be a reflection across the y-axis. Now, to be honest, on the AP exam, you're never going to see one function that incorporates all these transformations at once. That would be really, really, really mean. But, I mean, I guess it could happen, but I doubt it will. We just need to be able to recognize a couple of them at a time so we don't get too complicated. Now, the one more piece of information I want to share with you that's super important is that any function can be viewed as a sine function or a cosine function, because cosine functions are just transformations of sine function or vice versa. So when you're looking at a function, you have to really make a decision. Do I want to look at this function as a sine function or as a cosine function? It all depends where you want to start. If you want to start up at the max, go to the min, back to the max, that means you're working with a cosine function. If you want to start on the midline, go back to the midline at the very, very end of your full period, then you're working with a sine function. So keep that in mind as we're identifying some of these different transformations, is you have to first make a decision if you want to use a cosine or a sine function. Now, there are 3 tasks that you have to be able to accomplish when it comes to working with sine and cosine functions and their transformations. First, you have to be able to look at an analytical representation of a sine or cosine function and identify all the different transformations and identify the new period, the new amplitude, the new midline because of those transformations. The second task is being able to look at a graph of a sine or cosine function and identify the period, the midline, the amplitude, and all the different transformations that took place onto that function. Now remember, this is where I was talking about. When you look at a graph, you could choose to look at it as a sine graph or a cosine graph, all depending where you want to start. And I'm going to talk about that when we look at several examples. And then the third thing you have to be able to do is to read a paragraph describing different transformations that take place. Take those different transformations, apply them not just to an analytical representation of the function, but also to the graph itself. All right, so let's start practicing all of these 3 different tasks. That way you can become an expert in understanding the transformations of sine and cosine functions. All right, in this first example here, we see a sine function with several transformations. We're asked to find the amplitude, the period, and the midline. So let's first start with, I think, some of the easier things. The first thing is the amplitude, right? The A value is 3. The B value is 4, and the D value is -7. There is no C value inside the function. So remember, the amplitude is the absolute value of A, so the absolute value is 3. So this function is now going to go up 3 and down 3 from the midline. And speaking of the midline is your D value, so Y equals -7. So we're going to see a midline at -7. From up there, we're going to go up 3 to -4, down 3 to -10. All right, and the period is where we have to do a little bit of math work. It's going to be 2 pi divided by your B value of 4. So 2 pi divided by 4 reduces to pi over 2. So we're going to see a shrink. We're going to see a shorter period. So normally 2 pi is a period. We're going to see the entire period of sine. This up to the max, down to the min, back to the midline. That's all going to happen within pi over 2 instead of 2 pi. All right, so let's take a quick look at the graph of this so we can actually see this happen. So first we see that new midline down here at -7. And then we go up 3 to -4, down 3 to 10. And we see that this whole cycle of up to the max, down to the min, back to the midline happens over a course of a period of pi over 2. All right, next problem here. We see an A value of 4, a B value of 2, and a D value of 5. So once again, the amplitude is going to be the absolute value of A, which is 4. So we're going to have an amplitude of 4, up 4, down 4 from the midline. And again, speaking of the midline is going to be that D value of 5. So it's going to be a vertical translation up 5 and a vertical dilation by a factor of 4. And then the period is going to be 2 pi divided by our B value of 2. 2's are going to reduce and we just get pi. So once again, it's going to be a horizontal dilation by a factor of 1/2. So we're actually shrinking our period by 1/2. It was 2 pi, now it's pi. So we take a quick look at this picture here. We see our midline is here at 5. And then, kind of not very straight line there. And then from there we go up our amplitude to the max and then down our amplitude to the min. And then this whole idea of sine happens over a course, this was a cosine, I'm so sorry. So this whole idea of cosine starts up at its max, goes down to its min, back up to its max. That whole period of cosine happens from 0 to pi. All right, this next problem here, we see an A value of 2, and this is a cosine function, by the way. Now, be careful with the B value. The B value is anything being multiplied by the x. So the B value is a whole bunch of stuff. It's 2 pi over 3. So all of this, whatever's being multiplied by the x is going to be your B value. And then we have a D value of -2. So the amplitude is always the easy part. It's the absolute value of A. Absolute value of 2 is 2. So we're going to go up 2 and down 2 from the midline, which is -2. So we're going to go up 2 to 0, down 2 to -4 from that midline. And the period, this is going to take a little bit of work. So we're going to take 2 pi divided by our B value of 2 pi over 3. Now, instead of dividing by a fraction, we're going to multiply by the reciprocal. So we're going to take 2 pi multiplied by the reciprocal, 3 over 2 pi. The 2's and the pi's both reduce, and we just get a period of 3. Now, this is going to be a horizontal dilation by a factor of 3 over 2 pi, which is actually going to make our period slightly smaller, right? Because normally it's 2 pi, which is about 6.28. Now our period is going to be exactly 3. All right, so we look at the picture here. We see the midline down here at -2. Kind of shaded in there. And then from that midline, we go up 2 to 0, down 2 to -2. And again, here is that cosine function starting at its max, dropping down to its min, back up to its max, and that whole thing is happening over 3 units. Pretty cool, pretty simple to see that in understanding everything that's going on there. All right, next example here, we have an A value of 1/4. That's going to be a vertical dilation by a factor of 1/4. Our amplitude is going to be much smaller. Our amplitude is only going to be 1/4, so very, very small amplitude, up 0.25, down 0.25. So our entire function is only, a half or 0.5 in range there, pretty small. Our D value is -7. That's, of course, going to affect our midline. So our midline is going to be y equals -7. So the whole graph is going down -7, but then it's only going to go up a quarter and down a quarter from that midline. It's going to be very, very thin here. And then our B value is 1/5, right? It's that 1/5 that's being multiplied by X. That's going to be a horizontal dilation by a factor of 5. So we're actually going to see this get bigger here. Our period's going to be longer. It's going to be stretched out. So we're going to take 2 pi divided by 1/5, but that's 2 pi times the reciprocal, 5 over 1. So that's 10 pi. So we see our period is much, much wider and longer. So take a look at this graph. So down we see that midline down there at -7. I'm not even going to shade it because it's so small. Then from that midline we go up a quarter and we go down a quarter. So very, very small range there. And then that whole cycle of sine starting on the midline, going up to its max, down to its min, back to the midline. That whole cycle of sine happens very, very elongated from 0 to 10 pi. All right, next example here. Again, kind of looks a little bit more complicated, but let's walk through it. So we have an A value of -7. The absolute value of -7 is 7, so our amplitude is 7. Our midline is going to be based on that D value, so our midline is going to be y equals 8. So we're going to go up 7 to 15 and down 7 to 1. So pretty wide range there. It's going to be 14 units on our range. And then the period, so our B value is pi over 4. Everything that's being multiplied by X. So our period is going to be 2 pi divided by pi over 4. And of course, I'm going to multiply by the reciprocal, which is 4 over pi. Pi's cancel, we get a period of 8. So it's going to be a horizontal dilation by a factor of 4 over pi. So it's definitely going to make my period bigger. Normally a period is 2 pi, 6.28-ish. Now my period is a nice solid whole number 8. So remember, midline is at 8, and then from that midline at 8, we can actually see it in this graph here. There it is. And we go up 7 to 15. That's our max. Down 7 to 1. That's where our mins are located. Now, the other thing I want you to notice here is that, remember, this was a sine function, but there's one more thing we forgot to mention, and that's the negative. That negative is going to be a reflection across the x-axis. So normally sine starts by going up to its max, but now because that reflection across the midline, we actually see that we're going to go down first. So let me go back to this graph here. I'm going to highlight what we see here. So here's that sine function going down first to its min, all the way up to its max, and then back to the midline. So that's the sine function, the basic sine function we see. It's got that midline of 8, amplitude of 7, going up to 15 and down to 1. We see that period of 8. That whole cycle takes 8 units. That was our period. And the negative is going to be that reflection across. Now, normally we say it's reflection across the x-axis, but that's for the traditional sine that is a midline on the x-axis. But when we move that midline, the reflection is happening across that midline. So that's why we see that reflection where sine is now going down instead of up. So pretty cool graph there, pretty neat. All right, next problem here. This is where we kind of see it all, right? Everything's going on here. So let's A is 2. That's going to be the absolute value of A is going to be our amplitude of 2. Our D value is -3. That's going to be our midline of y equals -3. Our b value is 2. That's going to affect our period. So we're going to have 2 pi divided by 2. So our period is going to be just pi. So it's shrunken down a little bit there. But for the first time, we see a c value of pi over 2. So that's going to be a horizontal translation, left pi over 2. Left pi over 2. Remember, it's a plus pi over 2, but it's always opposite when we're inside the function. Just like that vertical dilation is not by a factor of 2. The vertical dilation is by a factor of 1/2, which is why it's 2 pi divided by 2. We're cutting that period in half. So the whole graph is going to go left pi over 2. So let's think about this before we look at the picture. Normally, sine looks like this, right? There's our sine function. Now, that whole process going up to the max, down to the min, back to the midline is going to happen quicker over a period of pi. The amplitude gets stretched up to 2 and down 2 from that midline. So we see that midline is going to be at -3. When we go up 2, we're going to go to -1. We go down 2, we're going to go to -5. But the other thing is this starting point. This starting point right here usually happens at 0, 0 for our sine function. But that starting point is now going to happen left pi over 2. So we're going to see that starting function get moved over. All right, so here is that graph. So let's point out all these key features. So first we see that midline at -3. And from that midline, we go up to our amplitude. You know, we see the max goes up to -1 for any of those maxes, and it goes down to -5 for any of those mins. Now, remember, this whole graph went left pi over 2. So we should be starting the graph over here at -pi over 2, go up to our max, back to our midline, down to our min, and then back to the midline. So there is that one cycle of sine, and it starts left at -pi over 2, and it ends at pi over 2. So that's a total distance of pi, right? That's our period of pi. Now again, it keeps repeating itself. I mean, hopefully that goes without saying. So here's another cycle right there, and then another cycle right here. But if we want to think about that starting cycle based on those transformations, it's left pi over 2, and then that starts us at -pi over 2. Then we go up and then back down and so forth. So pretty cool to understand that graph. It's really easy to see the midline and the amplitude. Like most kids have no problem identifying those. But seeing that translation. Now, I want to talk about something really, really important here. And this is going to kind of carry over to some other problems. Every graph, right? Now I know we made this graph based on a specific function, but every sine and cosine, every sinusoidal function graph could actually be written many, many different ways, right? So here's what's kind of cool is I want to show you how I could use the same picture, but write a different function. So let's look at this cycle right here. Sorry for all the colors, but let's look at this cycle of sine right here, right? It goes down to its min, back up to its max, back to the midline, but it starts at 0, 0. And if you start at 0, 0, if you start on the y-axis, sorry, it doesn't start at 0, 0, but it starts on the y-axis, well, that means I don't have any translations left or right. So if I look at this, the one thing I cannot change is my midline. My midline is still going to be my d value of -3. I cannot change my amplitude. My amplitude is still going to be 2, up, 2, down. So those things are unchangeable. And I cannot change my period. Right, my period was pi, and that was based on my b value of 2. Like I can't change those things. Those things are unchangeable. But check this out. If I want this to be my sine function right here, I do need a reflection. I do need a reflection because it starts going down. So I need to put a negative on my a value. Now my amplitude is still 2, because remember the amplitude is the absolute value, but I do need that negative on the a value, which is going to cause that reflection. But because I'm starting on the y-axis, I don't need to add in a translation. So this function would be y equals -2 sine of 2x minus 3. This function right here would be identical. It would produce the same graph. It would produce the exact same graph as this one that we started off with. Because again, notice it's the 2 right here, the amplitude I can't change, the b value I can't change, the d value I can't change because that's the midline. But if I start somewhere else, I started on the y-axis, I no longer need that translation left pi over 2. And then I did have to add in that negative to cause that reflection because it does start going down. So a lot going on there. Hopefully that makes sense. Kind of confusing, but hopefully that makes a lot of sense because it's really important to understand that. In fact, I'm actually going to do one more. I know this is getting kind of messy, but I think this is really valuable to understand this. let's look at this right here. Here's another sine function right there. There's a sine function, right? Starts on the midline of -3, goes up to its max, down to its min, back to the midline. Now, because it goes up first, I no longer need that negative on the a value. So my a value is still going to be a +2. I cannot change the period. The period is pi. Now it goes from pi/2 to 3pi/2, but that's still a total distance of pi, which means my b value needs to be 2. My d value is still that -3 from my midline, and I cannot change that. But if I want this to be the sine function I look at, I'm starting right here. Now, that starting point is over pi/2. It's over right pi/2. So if I wanted to write this function, it would be y equals 2 times sine of 2, that's my b value, times x minus pi/2. That minus pi/2, that's going to be that translation that takes me right pi/2 and then -3. That would be another function that would create this graph. So I actually have 3 functions now that create the same graph. The original one we started with and this one. But the things I cannot change the amplitude, I cannot change the period length, I cannot change my d value, the midline, but I can determine where do I want to start. And that's going to affect your horizontal translation, and that could also be impacted by a reflection if I'm going to start at a point that goes down first. So a lot going on there. I hope you understand all that, and we're going to even tackle that a little bit more here shortly. All right, let's look at one more problem here. Another problem. This one's going to be adding a little bit layer of difficulty here. So the a value is pretty easy to see. Seeing a value 4, absolute value 4 is going to be my amplitude. D value is really easy to see, -1. That's going to be my midline of y equals -1. Now, a lot of kids want to jump and say the b value is 3, and that is true. The b value is 3, but the c value is not 2 pi. Remember, the original breakdown for these functions is that we need to have that b value factored out. So it needs to look like this. So inside of the parentheses here, inside of the cosine, I'm going to factor out that 3. And if I do that, I'm dividing out that 3, I get 2 pi/3. There's my c value. I have to factor out that 3 to see it, because that's how it looks, right? Remember when we taught this, it was a times cosine of b, and then in parentheses is the x plus c, and then plus your d value. So if I don't have those parentheses inside, I have to create that by factoring out that b value. And again, I'm all staying inside the cosine, but I'm factoring out that 3 so I could identify my translation. A lot of kids forget about that, so that's really, really important. All I'm doing is dividing out the 3, so I'm factoring it out. So 3x divided by 3 is just x, 2 pi divided by 3 is, well, 2 pi divided by 3. All right, so my period is going to be 2 pi divided by my b value of 3. That's going to be 2 pi/3. But again, now I'm going left 2 pi/3. So be very, very careful with identifying that. There's a lot of multiple choice questions that ask simply about that horizontal translation. And a lot of kids are going to say, oh, left 2 pi. No, 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 no. You got to factor out that 3 to make it look like our setup. All right, so we have our midline at -1. From that midline, we go up 4 to +3, down 4 to -5. We have our period is going to take place at 2 pi/3. This is a cosine function. Cosine functions start up at their max, go down to the min, back to the max. So we should see all that happening over a period of 2 pi/3. But this starting position right here is going to be left 2 pi/3. So here is this graph right here. And we see that midline down here. Remember that midline was at -1. So we see this midline right about here at -1. Sorry, my drawing of straight lines is pretty bad. We go up 3, or excuse me, the amplitude is 4. So up 4 to 3, down 4 to -5 for those mins and maxes. But remember, we started because of that translation. We started left 2 pi/3. So that's going to be right here. And we go down and up. There it is. So that's what we see, right? But again, the function can be created with infinite different possibilities depending on our starting point. Like we could say, well, I want to start right here. And then I want to go down to my min, back up to my max. Okay, well, that means we're going to need the amplitude can't change, the midline can't change, the period can't change, but the translation can change. That would be starting to the right. So pretty cool. Hopefully, the key thing I want you to understand right now is just being able to look at that function and understand all the different attributes and characteristics and transformations. All right, so let's look at that second task now where we're going to work backwards. We're going to start with a graph. So here is a graph, and I want you to identify the key features of the graph and then create a function from the graph. All right, so let's identify the key features. So first, let's talk about the midline. So the midline is the average of your min and your max. So my max is 7. My min is -3. So if I add those together, 7 plus -3, just find the average. 7 plus -3 is 4. And I got to divide that by 2. And 4 divided by 2 is 2. So I see my midline is right here at 2. I'm going to actually draw it in there. Now, we know that that is going to impact our D value. So the midline, the average of your min and max was y equals 2. That means my D value is going to equal 2. Okay, that's pretty easy. All right, then it's pretty simple to find the amplitude from there. Now, the definition of the amplitude is half of the distance between your min and max. So the distance between 7 and -3 is 10. That's the total distance. And divide that by 2, you get 5. So amplitude is 5. And you can actually see that. So from that midline, we go up 5 to 7, down 5 to -3. So my A value is going to be 5. My amplitude is going to equal 5. And then the next thing I got to do is I got to look for my period. Now, I never told you if this is sine or cosine. You get to pick. Do you want to look for a sine function or do you want to look for a cosine function? Well, let's start this off by looking at a cosine function. We're going to do this problem multiple different ways. So if I'm going to look at a cosine function, I start at my max and I go to my min and then I go back to my max. So the distance between any two maxes is going to be your period. So what's the distance between these two maxes? Well, the first max is at 0. The second max is 2. So that's a distance of 2. Now, even if I chose to say, this max and this max, well, that's the distance between 2 and 4. That's still a distance of 2. So my period, my actual period value is 2. Now, that's not your B value. That's not your B value. I have to solve to find my period. So remember, the formula for a period is 2 pi divided by your B value equals the period. But in this case, I know the period is 2. So in the previous problems, we knew the B value. We took 2 pi divided by B to get the period. Here, we're working backwards. We know the period. Now we have to solve for B. So I'm just quickly multiply the B to the right-hand side. So I get 2 pi equals 2 times B. Divide both sides by 2, and I get a pi as my B value. So I know my D value is going to be 2. That's for the midline. I know my A value is going to be 5. That's going to be my amplitude. And I know my B value is going to need to be a pi. Now, is there a horizontal translation? Well, because I started my cosine curve on the y-axis, no, I do not need a horizontal translation, left or right, because I'm starting it on that y-axis. So here I go. So it's going to be y equals my A value. That's going to be 5. I chose to create a cosine graph. My B value is pi times x inside of there, and then plus that D value of 2. So that function right there is going to create this graph. Pretty cool. So I see the cosine function. I see the amplitude. I see the midline. That's all pretty easy. The period, again, be careful with the period. I see the period is 2, but that would be needing a pi. That way, when I use my formula, 2 pi divided by 2, the 2 is reduced, and I just get that period of pi. So hopefully that makes sense. Pretty cool. But I want to show you that there's actually infinite ways that I could do this problem. There's many other ways I could do this problem. So let's erase all of this. And the one things I cannot change, or the few things I cannot change, and I want to really emphasize this, I cannot change the midline. That doesn't matter. It doesn't matter if I look at this as sine or cosine, reflection, no reflections. It doesn't matter. I cannot change the midline. I cannot change the amplitude, and I cannot change the period. All of those are true no matter what I look. So let's just say I want to look at this cosine curve, starting down at my min, going up to my max, back to my min. So if the period is the distance between any two consecutive maxes, well, it's the same thing. It's the distance between any two consecutive mins. So look, the distance between those two mins, -1 to 1, is still a distance of 2. Again, that's why I cannot change my period, which means I cannot change my B value. But what's different about this cosine curve? 2 things. One, it starts down. That means I'm going to need a negative on my A value. That's that reflection across the midline. Then notice it doesn't start on the y-axis. It's starting left at -1. So that means I will need a horizontal translation left 1. All right, so let's apply all of this to create my new function. So y equals -5. Why the negative? Because I'm starting down. Normally cosine starts up at its max. There's my cosine value. Now I need that b value of pi. And then inside its own set of parentheses, I need x plus 1. That x plus 1 is going to move me left 1 because look at my starting point. It's left 1. And then I need that plus 2 for my midline. Pretty cool there. Pretty interesting, pretty fun. I kind of like doing this. All right, and I don't want to bore you to death here, but let's do one more. But this time I really want to change the game up. Let's look at a cosine or a sine curve. Let's look at a sine curve. All right, so here is that midline at 2. I don't want to forget where that midline is. And the reason for that is because remember, sine starts at the midline. So let's see here. Let's find a sine curve. So, okay, here would be a sine curve right here, starting on the midline, going up to its max, back to the midline, down to its min, back to there. So that's still a total distance of 2. So I cannot change my period, which means I cannot change that b value of pi. My amplitude is still up 5, down 5. I cannot change that. And the midline is still 2. But what's changing? Well, I'm using sine. That's for one. And traditionally, sine starts at the midline on the y-axis. But I'm starting right here, which is left a half, right? Starting at a half, right between 0 and -1. So in starting right here at -1/2, that means I need to add in a horizontal translation, left 1/2. So here I go. So y equals 5 sine, that's my amplitude. I'm using sine now. I still have that same b value of pi, but then I need x plus 1/2. That's going to move me to the left 1/2. And then plus my d value of 2, that's that midline. So that's another function that could be represented by this graph. There's infinite possibilities, right? It all depends on, do you want to use sine or do you want to use cosine? Where do you want to start? But the things you cannot change are the amplitude, the period length, and the midline. Once you identify those cannot change. But you could switch between sine and cosine, and you could switch your starting point, which could create a reflection or could need a translation left or right. So a lot going on there. I spent a lot of time on that problem. I think it's really necessary. In fact, let's just do one more of these. I won't do quite so many, but I really want to emphasize all the key details here. And you know what? Feel free to pause the video and try it on your own. All right, midline. Well, I have a max of 8 and 2, so the average of those, 8 plus 2 is 10, divided by 2 is 5. So I see a midline as 5, and some kids could just kind of eyeball it, but I want you to make sure you understand the math. All right, the amplitude is going to be how much we go up or down from that midline. So we go up 3 to 8, down 3 to 2. That's also the half the distance between your min and max. My max is 8. My min is 2. That's a distance of 6. Half of 6 is 3, so my amplitude is 3. So let me start writing this down. So the midline is y equals 5. The amplitude is 3. These are all things I cannot change. And let's talk about the period length. Now, let's identify a curve we want to use. Let's use a sine curve, and let's use this sine curve right here that starts on the y-axis. If you start on the y-axis, then you don't have to worry about any horizontal translations, which makes it a little bit easier. So there's my sine curve, and that entire sine curve started at 0 and ended at 2 pi over 3. So that means my period is 2 pi over 3. So again, if you start at the y-axis, it's really easy just to end and determine where your period is. So my period is 2 pi over 3. Now, my midline is 5, so my d value is 5. My amplitude is 3, so my a value is 3. I don't need a reflection because I did start going up, so I don't need to put on a negative there to that a value. But I do have to, this is where there's a little bit of work. I got to find my b value. So the formula for period is 2 pi divided by b, but I equal 2 pi over 3. That's the actual period. Now, if you just look at this, I hope everybody understands, oh yeah, b has to be 3. But let's just do the math real quick. Let's multiply the b to the right-hand side. So I get 2 pi equals 2 pi over 3 times b. I'm going to multiply by the reciprocal on each side. So I'm going to take 2 pi. I'm going to multiply by the reciprocal 3 over 2 pi. That's going to cancel this out, and I just get b. The 2's and the pi's both cancel, and we just get a b value of 3. So a lot going on there. Hopefully that made sense. But that's pretty easy. You just got to really, really think about that. All right. I think I'm ready to go to create my function. So y equals my amplitude of 3. That's my a value. I chose to use a sine function. And then I need my b value of 3 times x inside the function. And then I need plus 5 for my midline. There it is. Pretty simple. Not too hard to do there. Hope everybody understands that. Nice and simple. Looks really nice and pretty too. All right, let's just do one more just to show you how, you could create other answers. Let's do another sine curve. Let's see here. Let's look at this sine curve right here. Now, what did not change? Midline did not change. Amplitude did not change. Period did not change. So I cannot change my A, my D, or my B value. But what did I change? Well, now I need a negative on the A value because I started by going down. So it's going to be reflection across my midline. And instead of starting on the y-axis, I started right pi over 3. So here I go. Y equals, I do need a negative 3. Negative because I started going down, so that's on my amplitude there. Or my amplitude's still 3, but I need that reflection. Sine, and then my b value is still 3. I can't change that, but I do have that translation right. So I'm going to need an x minus pi over 3, and then plus 5 for my midline. The negative is going to start me going down, and then the minus pi over 3 is going to move me to the right pi over 3. So pretty cool. And again, I could sit here all day. I know you'd be bored, but I could sit here all day and come up with more. I could even use a cosine function to represent this graph if I wanted to. All right, let's start moving on to task 3. Here we see words, right? Write a sine function with the following characteristics. All right, so my amplitude is 5. That means my A value needs to be 5. My period is 6. This is where we got to do a little bit of work. I want to emphasize that. The formula for a period is 2 pi divided by b. I know the period is 6, so now I just got to solve, multiply both sides by b, divide by 6, and that reduces to pi over 3. So pi over 3 is going to be my b value, and because my midline is negative 5, my d value is going to be negative 5. So I wanted me to do a sine function. So I have 5 sine. And then I have the pi over 3 times x inside. It didn't say there was a horizontal translation left to right. And then I need minus 5 for my d value. Pretty cool there. Now, I could tag a negative right here, and that's not going to change my amplitude. It's not going to change my period. It's not going to change my midline. Now, the graph would change because it would start going down, but it didn't show me a graph that say that happened or didn't happen. So I'm going to erase that because it didn't mention it happening, but it wouldn't change these 3 characteristics of the amplitude, the period, or the midline. And I can even add a translation left or right, and it's still not going to change these 3 things. Now, is there a translation left or right? Well, it didn't say, but if I add one in, these 3 things are still going to stay the same. So I want to emphasize that. All right, one more type of problem that's actually pretty popular on the AP exam is something like this. So we see a sinusoidal function, and we're given 2 points, and we're asked to, create the function. All right, so we see this one starts at 0, 16, and that means all the maxes must be at 16. And then we see this min is 3, 6. Now, what could I gather from here? Well, the first thing I could gather is my midline, right? Because the midline is just the average of your min and max. So 16 plus 6 is 24. 16 plus 6, 22, and half of 22 divided by 2 is 11. So that midline is going to be at y equals 11. Now, from that midline, we go up 5 to 16, down 5 to 6. That's going to mean my amplitude is 5. And again, you could also just find the distance between 16 and 6. That's a distance of 10. Half of that is 5 for my amplitude. All right, now what about the period? Well, remember the period goes from max to max or min to min. So what's this next max? Well, everything is nice and symmetric, right? So if it took 3 units, 0 to 3 to get to the min, it's going to take another 3 units to get back to that max. So it'd be 6, 16 there. So that means my period value, or the length of my period, is equal to 6. Okay, so if you think about it, from a min or a max to a min, that's half of your period when you're talking about a sinusoidal. So a sinusoidal function, max to max or min to min, consecutive maxes, consecutive mins, that's your period length. But a min to a max, that's going to be half of your period length. So it took 3 units to get from that max to that min. So it'll take another 3 units to get back to that max. So there's my period of 6. So let's start talking about some important details here. So now my D value is going to be 11 to get me to that midline. My amplitude is going to, or my A value is going to need to be 5. Now it could be a negative 5 depending on where I start this graph, and we'll talk about that in a second. And then my B value, this is where I have to do a little bit of work. I always got to do a little bit of work here. So 2 pi divided by b equals my period of 6. So I'm going to multiply that b value over, then divide by 6 to solve for b, and that's going to be pi over 3 for my b value. So my b value is pi over 3. Now those things cannot change, right? Now let's talk about these points right here, just so we understand. These points are on the midline, and they are going to be directly halfway in between all of these mins and maxes. So halfway between 0 and 3 is going to be 1.5. So that's going to be 1.5 comma 11, because it's at that midline. This is going to be 4.5 comma 11, because that's also at my midline. So that's what I'm looking at, right? So now if I say, hey, this is one full cycle, max to max. Okay, we have identified the midline, we've identified the period, we've identified the amplitude. Now we simply have to create the function. Well, that's a cosine function. Cosine functions start at max, end at max. So we're going to have y equals my amplitude, or my a value of 5, cosine, and then we have our b value of pi over 3 times x, and then plus that midline of 11. Pretty cool. So there's the function right there. But of course, there are many other answers. There's many other functions that could create this. So let's actually erase that, and let's start somewhere else. Let's say, you know what we want to do is we want to start here. We want to start right here. We want to go down and then back and then down. Now, what's not going to change? Amplitude, midline, period. But now this is using a sine function that's starting down. So I do need to add a negative onto my a value because it's going down. It's reflection across the midline. And the other important thing is I'm no longer starting at 0. I'm now starting right 1.5. So this would be y equals negative 5 times sine, and then my b value is pi over 3, and I need an x minus 1.5. That's going to start me right 1.5. And then plus 11 for my d value. So that would be another function, a sine function that we could use that would represent this graph here. So again, I could sit here all day and make new functions because I could look or start anywhere I want, but it's really important that you understand all of these details, right? It's all in the details, and this can be very difficult, so I'm spending so much time on it. Let's just do one more. Let's look at this as my 1 period for sine right there. All right, so no, I don't need the negative anymore because I start going up. But I did start at 4.5, so I'm starting right 4.5. So it'd be y equals 5 sine pi over 3 is my b value, x minus 4.5 plus 11. That'd be another function. Now, what's the easiest thing to do? I'm going to tell you right now, it's always easiest if you start on the y-axis, because that means you don't have to incorporate a translation left or right. So that's why a lot of kids are going to start right here. They're going to recognize that's a cosine graph. They don't have to add in the translation because they're starting on the 0, the y-axis there. And that tends to be a little bit easier for students. But I really want to show you as many examples as possible because this can be very, very tricky. And this is a huge part of the AP exams. I really want to make sure I went over a lot of examples. All right, best of luck. Hope you liked it.